Hello everyone. Today I want to explore a new feature of AWS Private Certificate Authority, or AWS Private CA, called the Connector for Active Directory. This connector can help you more easily provision certificates for users and machines within your Microsoft Active Directory, or AD, environment. AWS Private CA can accelerate your provisioning and reduce the need for hardware security module, or HSM, management, and other time-consuming operational tasks. Today, many AD administrators provision users and machines with certificate-based authentication with Active Directory Certificate Services, or ADCS. However, doing so requires admins to build their own Certificate Authority, or CA, infrastructure, often including HSMs to store private keys. They also must manage key ceremonies, key generation, compliance requirements, and other elements of the process. AWS Private CA aims to simplify that whole process for you. With this highly available and fully managed service, you can issue private certificates to establish endpoints for TLS encryption, cryptographically signed code, authenticate users, and more. And now you can use the connector for AD to issue certificates to domain-joined devices in your AD environment. Note that this feature is distinct from the Active Directory connector, which is a directory gateway you can use to redirect directory requests to your on-premise Microsoft AD without caching any information in the cloud. You can create a connector for AD in the AWS Management Console, allowing you to seamlessly integrate AWS Private CA with AD and issue certificates from AWS Private CA using the same auto-enrollment and group policy-based methods you use today. You can use AWS Private CA to create a connector for Active Directory, configure the certificate templates required for your specific use cases, and automatically issue certificates using the AD auto-enrollment mechanisms you already use with ADCS. You can use Connector for AD to integrate with your on-premises AD environment using the Active Directory connector or with AWS Managed Microsoft AD. You no longer need to configure and manage a Windows CA or HSMs to protect your CA private keys, as the CA private keys in AWS Private CA are stored in FIPS 140-2 validated HSMs. This allows admins to focus on other tasks rather than management of CAs and HSMs. More importantly, your admins will not need to change the way they issue certificates to end-user devices, which reduces the effort needed to migrate away from your existing on-premise PKI. The connector for AD exposes an endpoint to integrate with AWS Managed Microsoft AD or your self-managed AD. The connector for AD acts as a broker for certificate requests between AD and AWS Private CA, enabling the auto-enrollment of certificates for users and systems managed by AD. The connector for AD can be used to issue certificates to domain-joined devices for both on-premise AD environments using the Active Directory connector provided by AWS Directory Services, and AD environments hosted in AWS Managed Microsoft AD. Using AWS Private CA and the connector for AD can help you decrease PKI costs, offload hardware management and compliance requirements to AWS, and reduce the time your administrators spend on operational tasks that could be better used for delivering value to your business. Let's take a look at this request flow diagram. This is an example architecture using AWS Managed Microsoft AD and a connector for AD to issue certificates to domain-joined devices from AWS Private CA. First, AWS Managed Microsoft AD provides the device an updated group policy object with auto-enrollment details. The device will then request certificate template info from the connector for AD. The connector authenticates this request with your AWS Managed Microsoft AD. Now, in step 4 of the diagram, the domain-joined device can receive information about enabled certificate templates and send a certificate signing request, or CSR, to AWS Private CA via the connector for AD. AWS Private CA can then issue the certificate and distribute it to the domain-joined device using the connector for AD. This process is similar when using the AD connector to extend your on-premise AD environment to AWS. Next, I'll walk through the process of creating a connector for AD and enabling certificate templates. I've chosen to use AWS Managed Microsoft AD for this demo, but you can find specific instructions for environments that utilize the AD connector in the AWS Private CA documentation. To get started with the connector for AD, there are a few prerequisites. You will need to use AWS Private CA to create a CA to issue certificates, or use an existing CA if you've already created one. You will also need to create or identify an existing directory using AWS Directory Service. For this demo, I've pre-created a directory using AWS Managed Microsoft AD. You will also need an IAM principal with an identity-based policy with permissions to create and configure the connector. Use the QR code on the screen to view the AWS Private CA documentation with more information on the required permissions. Lastly, you will need a security group with the appropriate rules to allow DNS, Kerberos, and LDAP. More information on the security group configuration is detailed in the AWS Private CA documentation linked by the QR code. Okay, now that I'm in the AWS Management Console, let's navigate to the AWS Private CA service. On the left panel, I will choose Connector for Active Directory. In the Active Directory section, I will select the Active Directory type as AWS Managed Microsoft AD. Now I will choose the directory I pre-created from the Select Your Directory dropdown. Next, I'll select the security group for the VPC endpoint that I configured with the appropriate rules. In the Private Certificate Authority section, I will choose the CA I pre-created to issue the private certificates. I can optionally add tags, but I'll skip this for now. Finally, I'll choose Create Connector. This process may take a few minutes. Now I've created a connector for AD that will enable you to issue certificates for domain-joined devices from AWS Private CA. You will also need to configure the appropriate certificate templates for use in your organization, based on your specific use cases. I'll demonstrate the configuration of templates now. I will choose Create Template. For this demo, I will choose to start with a predefined template, Workstation Authentication. Now I need to configure some settings for the template I want to create, including name, schema version, and client compatibility. Next, I will define settings for the certificates that will be issued based on this template. Review the AWS Private CA documentation for more details on each of these settings. I also need to configure the request handling and enrollment settings, as well as the settings for key usage extensions and cryptography. Note that these settings may vary depending on your use case, and my selections are only for demonstration purposes. You should configure these according to your own requirements. I will configure the permissions for enrollment using the Configure Groups and Permissions section. Lastly, I can choose to configure superseding templates and tags for the AD resource. I will skip this for the purposes of this demo. Now I will click Create Template. And that's it. I've created a connector for AD and created a new template for issuing certificates. Please use the QR code on screen to review the Getting Started guide for more details and a step-by-step guide to create and configure a connector. You can also find the link to the Getting Started guide in the description of this video. In this video, I introduced the new AWS Private CA feature, Connector for AD, and discussed how it can help you simplify PKI management, reducing both operational intricacies and costs. To learn more about the services mentioned in the video, refer to the AWS Private CA and AWS Directory Services documentation pages. You can get started creating CAs in AWS Private CA using the AWS Management Console, AWS CLI, or APIs.